Hello, today we're going to be reviewing piecewise functions. Now if you remember from pre-calculus, piecewise functions, well there's our f of x for the function, but piecewise functions have curly braces here, and it gives us two options. So something along the lines of 1/2 x plus 3 if x is greater than 1. Or maybe something like x squared if x is less than or equal to 1. And we look at these two things separately. So it's probably easiest if we make an xy chart or an f of x chart. Now for my top part of the piecewise function, I need to pick numbers that are bigger than 1. I know that I need numbers bigger than 1, but 1 is my starting point. And I need to pick numbers, everything from there and after. And it's very hard for me to pick 1.1 or 1.01 or 1.001. So why not just pick 1, see what it is, and we'll go from there. And then numbers bigger than 1, like 2, 3, 4, and that should be good. Well, let's plug those in. We'll do 1/2 of 1 plus 3. Half of 1 is 1/2 plus 3 gets me 3.5. If we do half of 2 plus 3, half of 2 is 1 plus 3 is 4. Half of 3 plus 3 gets me 4.5. Then half of 4, which is 2, plus 3 gets me 5. Notice that each time I go up in my y value, I go up by 1/2. And that has everything to do with the fact that 1/2 is the slope for that linear equation. Okay, and to graph this, I have my first ordered pair as 1, 3.5. But again, x can't be equal to 1. It has to be greater than 1. So to show that this is my starting point, but it's not part of the line, I'm going to put an open circle at 1, 3.5. We've seen open circles on our number lines. If x wants to be greater than 1, we start with an open circle, right? And that's what we have here, an open circle at x equals 1. But we build up from there, everything after that. So 2, 4, so 3, 4.5, and so on. I can keep going up 1/2 and over 1. My line looks not great, but good enough, we'll pretend. Alright, let's look at the bottom piece. So I'll use green for this one, and once again I'll just make an f of x chart to make it easier. Okay, and I'll input, I need to pick numbers that are less than or equal to 1. So once again I'll start with 1 as my beginning point, and then numbers less than that, so like 0, -1, -2. And if we input these things, 1 squared, that's 1. 0 squared is 0. -1 squared is +1. -2 squared is 4. So we have 1, 1. Can x be 1 this time? Sure can. It can be less than or equal to. So that counts. We put a closed circle. 0, 0, -1, 1, 2, 4, and we have our portion of a parabola here. Okay, so this equation, or this graph right here, is the graph for this piecewise function. So that's your basic review of what a piecewise function looks like. So let's talk about something else here. Let's talk about domain and range. So what is the domain for this function? What can we plug in? Well, if I go left, if I go all the way left, if I go all the way right, I'll be able to find any x value. I can input whatever x value you want. So this domain is all real numbers. The range, however, is a different story. Notice that my lowest y value is right there. There's no y values lower than that. The green piece goes up, the red piece goes up, so my range has a minimum of 0. So my range is y's greater than or equal to 0. Or if we're doing interval notation, we have 0, a firm 0, all the way to infinity. Another thing I want to quickly touch on, What if I asked you to find something like f of, let's say, 8? If I asked you to find f of 8, well, which one do we put it in? Well, that means my x value is 8, and we want up here in this top one is where my x's are bigger than 1, so that's the one we would use. We would do 1/2 of 8 plus 3, so we get 4 plus 3, or 7. What if I asked you to find f of -10? Well, that one is down here, where my x's are less than 1. My x in this case is -10. So we would do -10 squared, and the result is 100. Okay, so that's your basic review of piecewise functions. We are done.